Hello everyone, welcome to Hi-Fi Tech Group. My name is Irfan Lak. We will be discussing overlay tunnels. This topic is part of CCNP 35401. We will be reading the same overlay tunnel topics for CCIE as well. So I'll fully recommend to go through these topics. These are very helpful topics. In our last video, we discussed GRE tunnel. So the GRE tunnel is for the packet encapsulation, and but it is not secured. So the packet, that data, it go from one router to other router in the form of plain text. There is no authentication, and there is no key exchange in between the routers. Packet can be eavesdrop, and someone can steal the data and manipulate it. So to overcome all those issues, another tunnel has been introduced, which is called IPSEC tunnel. It have built-in CIA. A is basically authentication. It have the built-in authentication in it, and the data is it is kept integrated. There is integrity. We will discuss all these things in detail below. So let's first of all let's see the differences between the GRE tunnel and the IPSEC tunnel. Okay, so GRE tunnel, as we mentioned earlier, it does not support authentication, confidentiality, integrity. Basically, there is no security. So that is the problem. But to overcome this, IPSEC it do support all those things. But IPSEC have its own issues. Multicast traffic, broadcast traffic, routed traffic is not being supported by IPSEC. So that is the problem. If someone want to transport, someone want to send the multicast traffic through IPSEC, it cannot be sent. So that is an issue. But GRE, it do support that. So there are some pros and cons of both solutions. So let's say if we combine GRE tunnel, if we pump the traffic of the GRE tunnel through IPSEC, so then we can combine the advantages of both solutions. So if we send GRE using IPSEC or GRE over IPSEC tunnel, so we will be able to send the multicast traffic and it would be secured as well. So it's a win-win situation. Let's see the different protocols that we will be using in the IPSEC. So as we mentioned earlier, CIA, confidentiality, integrity, and authentication. In IPSEC, these are the three authentication protocol that it support. Authentication mean when the session is being established, we send a passcode to the far end, and the far end enter a passcode as well. So basically a pre-shared key kind of protocol it supports. So this normally for the session creation we use the authentication. So authentication normally we use during the session creation, during the session creation, because during the data transportation we don't want to send key for each and every packet that we are exchanging. So authentication is not being performed during the data exchange. So during the data exchange there is no authentication, but during session there is authentication. So the next is confidentiality. Confidentiality is encryption. So if we, for example, write, uh, let's say PLAIN, plain, and we send it to the other end. So if we send it in the form of plain text, so anyone who is spying the data that I'm sending to the far end will be able to read it. But if it's been encrypted, then the eavesdropper will not be able to understand what I'm sending. So instead of plain, if I, let's say, send 1, 2, 4, 1, 3, 7, so only me and the receiver will know it's mean plain. But anyone who is eavesdropping, who is spying, cannot conclude that this code mean plain. So this is being done using encryption. There are different encryption protocol. Dash 3 dash N enhanced encryption standard. Then the third one is integrity. Integrity mean whatever we are sending, it is received as it is. For example, we have two router A and router B, and I am sending CCNP from this router. Once it received at the far end, it is being converted to CCN instead of P, CCNB. So someone tampered the data, replaced P with B. So this is basically called data tampering. There are four alphabets on both sides, but the one of the letter has been replaced with another one. So to overcome that, we use hashing algorithms. So we calculate a hash when we send data, and we send its corresponding hash as well. And once the data is received, we calculate the hash again. So these two hashes, they should match to each other. If they don't match, it means data has been tampered. So these are the protocol that IPSEC have introduced. Okay, these are some of the terminologies that we use for the IPSEC. IPSEC, okay, for the packet header, we have authentication header and encapsulation security payload. So ESP, so ESP protocol, this protocol we use for the data communication during the data communication. For the IPSEC, we have two modes, tunnel mode and transport mode. If we want to combine GRE and IPSEC, so what we need to do is with GRE, we need to use the transport mode. Then it can be transported via IPSEC. So GRE plus transport mode would be equal to IPSEC. Then the transform set is, it is a combination of protocol, the security protocol or security association that we will use for the data communication. So there are some security protocol that we will use for the data communication, and there are some security protocol that will we use for the session during the session establishment. So normally during the session establishment, we use three security protocols and basically C, I, and A. But during the data transport, we use C and I. We don't use authentication. So as we said, authentication required key exchange, which we don't want for the data because the data is in gigabytes. So session is like kilobytes. So for session, we can exchange the keys, but for the during the data communication, which is in the in terabytes even, so we cannot send for each and every byte one um, one security key, because security key generation, it's a very CPU intensive process. So we need quantum computer actually if we really need to generate the security keys during the data communication as well. And other thing is, when we when we create the IPSEC tunnel, it is divided into two phases. Phase one is for the session, for the session establishment. It's done during phase one. Then phase two for the actual data transportation. So two phases. So the first one is for session, the second one is for the data communication. Okay, we have different type of VPN. Side to side VPN is commonly available. Then DMVPN, Get VPN, Flex, and Remote. These four, they are Cisco proprietary. And side to side VPN is the generic one. Side to side VPN, it can be between head office and branch office. And remote access VPN is many people who are working from home, especially these days, from their PC, they connect to their office domain using a VPN client protocol. On office size, VPN server application would be installed. So session would be established from client to server. This is the sample configuration of site-to-site IPsec. So this portion is phase one. IKE phase one. This is phase two. And here in this portion, we are basically creating the GRE tunnel, and we are okay in the upper portion. This is IPsec. Lower portion is GRE, and here we map IPsec security to the GRE. So overall, this is what we're doing. Let's see in depth. Okay, so here in phase one, if you see, we are defining C. This is confidentiality. This is integrity, ECI, and this is A, authentication. So CAIA has been defined here, and this is basically the key. This is also for the authentication we're using. So CIA we are defining here. In phase two, here this is encryption. So which is basically C, and this is ESP SHA HMAC. So hashing, it is integrity. And then you see here we are using the transport mode. Transport mode, why we are using? As we said earlier, GRE plus transport mode is equal to IPsec. So to use IPsec on GRE tunnel, the mode should be transport mode. So you see, in phase two, this is for the data communication. In data communication, we are defining confidentiality and integrity. If you notice that uh, in during phase one, during the session, we are establishing confidentiality and integrity. And even in phase two, we are defining confidentiality and integrity. So we are checking two times. So integrity and confidentiality. This is just to make sure that the data would be more protected. So two times we are checking the confidentiality of the packets from source to destination. And here, if you notice, we have made a crypto map here. Its name is VPN. And this map, we are mapping it to the interface, and the interface is associated to the GRE tunnel. So GRE tunnel is basically associated to interface. Interface is associated to this crypto, and this crypto is basically associated to the IPsec security. So that's how IPsec security is implemented to the tunnel. So guys, that's all for today. Um Please subscribe our YouTube channel and click on the bell icon button. Our next topic would be LISP. So please follow my YouTube channel. Thank you very much. Bye.